Back-to-back stem and leaf plots. There are 24 children in Class A. Each child is given the same problem to solve. The time each child takes to solve it is recorded to the nearest tenth of a minute. The 27 children in Class B are also given the same problem, and their times for solving it are as shown here. Represent these data using a back-to-back stem and leaf diagram. Use the diagram to compare the times of the two classes. Now the first job is to try and find the smallest and largest data values. So the largest one seems to be 9 point something, just here. And looking for the smallest, we've got a 5 point something in here, we've got another 5 point something here, and we don't have anything that's 4 point something at all. So it looks like the smallest is a 5.2, and that's going to enable us to draw our stem. Now the first thing to do is do an unordered plot. So don't worry about this being the finalized plot, and no need to do it particularly neatly. So we know the smallest was 5 point something, so 5, 6, 7, 8, and the largest was 9 point something. So if I decide to do Class A on this side and Class B on this side. So now I just need to get the data from here into the diagram. So 7.4, I put a 4 as the leaf. 8.2, 6.1, 9.3, 7.4, 8.5, 7.2, 6.8, 6.4, 7.7, 9.6, 8.8, 8.9, 7.2, 7.3, 7.0, 5.9, 8.9, 7.6, 9.3, 7.4, 7.9, 9.1, and 5.7. Now, just while recording was paused, I put the values for Class B in, and now we want to draw an ordered stem and leaf, and we want to do it very neatly now. So I'm just going to put the stem in, like so. And we know it's got 5, 6, 7, 8, and 9. We know this is Class B, and this is Class A. Now we order from the center outwards. So this says 9, 7, but we want it to be ordered. So 7, 9. Then here we have 1, 8, 4. That needs to be 1, 4, 8. Now when you're drawing these, always make sure that numbers go directly below each other. So the 4 goes below the 9, and try to get the spacing even as well. Now for the 7, we've got 0, then 2 2s. So 0, 2, 2, keeping them nicely in columns. So what did we get from here? We had the 0, the 2, and the 2. Then we've got 3 4s, nice and neatly spaced. So 4, 4, and this 4 over here. And then we missed the 3, so let's quickly get rid of those 4s. We need to pop the 3 in there, and then the 4s. And then we've got a 6, a 7, and a 9. Like so. Then for this one, it's already in order, 2, 5, 8, 9, 9. Just make sure we work nicely in columns. And then 1, 3, 3, 6. Now we're ordering this, remember, from the center outwards. So we've got 2 that will go closest to the 5. Then we've got 4, 5, 8, and 9. Again, evenly spaced on this side, as evenly as you can make it. So here we've got a 0, then a 1. Again, working nicely in columns. And then we've got a 4. And then we've got a 6 would come next. Then I've got 2 7s, followed by 2 9s. Now, going here, we've got 1, 2, 3 to start with. So let's just cross those off. 1, 2, 3. Then we've got 6, 7, 7. And then here we've got 1, 2, 2, 4, 8. And then finally, it's going to be 1, 5, 3, but it's going to be in the order 1, 3, 5, so coming outwards from the middle. Now, a key is very important. Sometimes you see them above, sometimes you see them below. So what I'm going to do here is I'm going to do 2, 5, 7 means 5.2 for class B. So that's the 5.2 going this way. And 5.7 for class A. Now we want to compare the times of the two classes. Well, we have the actual data values, so we can make statements like Class B had the fastest time of 5.2 and Class A had the longest time of 9.6. But the whole point of spacing things nice and equally is we can also see the distribution like a bar chart. And what should be clear from this is that Class B has more of its data at the top end of the graph here, which corresponds to the lowest times, and therefore we can say that Class B was on the whole quicker than Class A. And of course we can calculate other things like mean, mode and median in order to support that, but that's what we can see visually.